In this class today, what we're going to look at is more ways to factorize a polynomial, and in particular a cubic function today. So last lesson we basically used this method. We looked by seeing if there was a common factor, then using the remainder theorem to find at least one linear factor, dividing using long division. But today what I want to do is just rework some of those examples from yesterday via the equating coefficients method. Okay, so for this one here, what we did was we showed that x plus 1 was a factor by doing p of -1, where that function was, let's just say, let that equal p of x. And recall that when we did that, it equaled 0. Okay, so that means that this was a linear factor. So what we can do is actually now attempt the equating coefficients method. And the way it works is I put my linear factor there and I draw out some brackets where I'm going to put my what is usually a quadratic factor in this slot here. Okay, and the way this method works is it goes through a little bit, well, not trial and error, but a little bit of thinking's involved here. Now, x multiplied by what in this position here will give me this cubed? Well, the answer is going to be and must be x squared. Now, I'm going to get my constant term, and this is going to be generated by doing 1 multiplied by this value here. Now, 1 multiplied by what will give me positive 6? Well, the answer is positive 6. The only thing I don't know is what this middle term is, which is, we're going to say it's plus bx. Okay, so I don't know what the coefficient of this is going to be. But I can actually work it out fairly quickly. Okay, and the way I'm going to do it is think about the ways I would, or what method I would use to generate an x term. Okay, so it would be, and I'm going to change color here just to hopefully emphasize this point here, that multiplied by that will give me an x term, which is 1 times bx. Okay, now the other way I'm going to generate an x term is x multiplied by 6. Okay, so I'm going to say that that's going to be plus 6x. Now, what that's going to be is that is going to equal the x term up here, okay, which is 1x. All right. Now, what I'm going to do is note that this is 1 plus, or 1 multiplied by bx, that's bx plus 6x equals 1x. Now I'm going to factor out the x and say that this is b plus 6x equals 1x. And what we're going to do is equate these coefficients, okay? And so it's b plus 6 must equal 1. The coefficient must equal the coefficient if x is the same as x, which we conclude then that b is equal to -5. So then we can actually rewrite p of x as p of x equals x plus 1 x squared take 5x plus 6. I've seen students do that move in probably 5 seconds to 10 seconds and be able to factorize that. Now recall yesterday what we did, or in the last lesson what we did was then factorize the quadratic using cross method. So that was, I think, 3 to xx pos, ooh, I've just come unstuck here. What was it going to be? 3 and 2, neg. So that was x take 3, x take 2. Okay, so that's basically the equating coefficients method. And the alternative is you put x plus 1 into it, into x cubed, take 4x squared plus x plus 6, which is a completely legitimate method. And I find that maybe 2/3 of my students will continue with long division and move away from equating coefficients. But equating coefficients is extremely fast and is a transferable skill to many other areas in this course. All right, let's try another one using the equating coefficients method. Okay, so we want to factorize this one here. So we're going to say let p of x equal x cubed take 2x squared take 5x plus 6. All right, now recall what we're going to do is try to find a linear factor by trial and error. So I'm just going to try p of 1. 1 take 2 take 5 plus 6. And we've got it. P of 1 equals 0. Therefore, x take 1 is a factor. All right, so yesterday then we would have used long division, x take 1 into this cubic here, but let's try the equated coefficients method. So p of x must equal x take 1 multiplied by a quadratic. All right, so what I've got to do is slot in those answers there. So x multiplied by what will give me the cube term? That must be squared. -1 multiplied by what will give me +6? The answer must be -6. So -1 multiplied by -6 will give me +6. The only thing I don't know is this middle term here. All right, so now I go off to the right and quickly scribble together the ways I would generate those x terms. Now, there's going to be two ways that they're generated, which is that multiplied by that, which is -1 times bx, and there's going to be this one here, which is plus -6 times x, and that's going to equal this term over here. So when those are expanded out, when I collect them together, must equal the x term over here, which is -5x. All right, what we'll do is we'll simplify the left-hand side. That's -bx take 6x equals -5x. All right, let's pull x out as a common factor and say that this is -b take 6 equals -5x. So those are equal to each other, so that means that these are equal to each other, which is basically why it's called equating coefficients, because we're letting the coefficients equal each other. That's -b take 6 equals -5. -b equals 1, b equals -1. Okay, so then we can rewrite p of x equals x take 1, x squared take x take 6. And then we can factorize that one as we did the other day. That's x take 1. What is it? That's going to be 3, 2x, and this one is negative x take 3, x plus 2. So there's the method there. And again, like I said, about a third of my class last year used that method quite successfully. All right, so now in context, what we're going to do, I don't know why that just happened. What we're going to do is look at some special cases, all right? So this one here is a situation where I have to factorize the sum and difference of two cubes, and there's a couple of identities. So if our polynomial looks like this, a cubed plus b cubed, then I use this identity here. If it's a cubed, take away b cubed, then I use this identity here. But I've said that some teachers can just remember them, but if you tell me, hey, what's the identity for the addition of perfect cubes, I'll just say to you bluntly, I've got no idea. Okay, so what I do is I equate coefficients and factorize. Okay, so here's what, or the method that I use. Okay, so we're going to say let p of x equal x cubed take 27. What I'm going to do is attempt to factorize this as normal. So I believe that p of 3 will make the remainder 0. So that's going to be 27 take away 27, which is 0. Therefore, x take 3 is a factor. All right, so let's rewrite p of x equals x take 3 multiplied by something here. Okay, so x multiplied by what gives us x cubed? Well, that's simply going to be x squared. -3 multiplied by what gives me -27? I believe that that is +9. Okay, and all I need is to work out what this middle term is. All right, so then I go to the idea of working out how to generate an x term. And the next term is generated by that multiplied by that. So -3 multiplied by bx will give me an x term. Another x term is generated by multiplying those two together. So that's going to be plus 9x, and it equals. Then what I do is I track back to my original function, and what I do is I search for the x term. Now notice that there isn't one in it in this case. Well, that's all right. The x term then we can say is 0x. That's -3bx plus 9 x equals 0x. This is then going to be x negative 3b plus 9 equals 0x. Negative 3b plus 9 equals 0 after I've equated the coefficients. 3b equals negative 9, b equals 3. Okay, so now that we know that that's the b value there, we're going to go p of x equals, where is it? X take 3, x cubed plus 3x plus 9. And you'll find that the identity will work. You can slam in the a value, the b value in the right places. But if this is exam 1 and I don't have any notes and I don't have these identities with me, I need a different way of doing it. The other method you could use is long division on this, but long division does get a tad messy on it. I highly advocate using equated coefficients for it. Okay, this next problem. So what we're going to do with this one is yank 8 out as a, let's go, let p of x equal 8x cubed plus 64 plus 8. So I've just pulled 8 out as a common factor and given the function a name, p of x. All right, so this is what I'm going to attempt to factorize. And again, what you could do is tie it in with the identity here and use the identity to slot the appropriate values in and the signs. But again, if push comes to shove and you tell me I can't use the identity or I can't look at it, then I need another method to be able to do this. All right, so that's what we're going to attempt to factorize. So I'm going to say that p of, now what am I going to do? I need this to be 0. So p of negative 2 equals 8 times negative 2 cubed is negative 8 plus 8. That is 8 lots of 0, which is 0. Therefore, x plus 2 is a factor. All right, so now let's set it up using the equating coefficients method. So p of x equals, and I'm going to do this bracket here, which is x plus 2. We've got 8 out here, and we want to do something to make this thing inside the brackets here. All right, so x multiplied by what will give us x cubed? That's going to be x squared. 2 multiplied by what will give us 8? The answer is 4. And we've got a bx in there. All right, now let's work out how I make my x terms. So I'm going to just do that in a different color. So x multiplied by 4 will give us one of them, and 2 multiplied by bx will give us another one. So 2bx plus 4x equals the coefficient of the x term in this one here, which is 0x. All right, factor out the x. 2b plus 4x equals 0x. Equate the coefficients. 0 equals 2b plus 4, b equals negative 2. So 8x plus 2, x squared, take 2x plus 4. Okay, now note that this says to factorize, and note I neglected in the first example here to actually factorize that. And what I know is that it won't be able to be factorized. Now, how do I know that? Because x cubed take 27 is an inflected cubic that comes up like that and has one x-intercept. And I just know that because it only has one x-intercept, that this will never be able to be factorized. Okay, and it's the same with this one here. This is an inflected cubic that is going to be like, how many units up? Can't remember, but it is in the same form. It's going to be like an inflected cubic, only one x-intercept, which is this one here at negative 2. So I just know that this one here will not be able to be factorized, therefore I don't further engage in in even attempting to do it. Okay, so that's how I do it using the equating coefficients method. Again, you can attempt long division on that and put a bunch of placeholder zero terms, so 0x squared and 0x in, and that will work quite nicely for you as well. But this is the method I would certainly prefer you to be able to use with a perfect cube. All right, now for the final section of factorizing, and it's these problems here called rational root theorem, okay? Now, they won't tell you that it's rational root, but what you want to look for a problem like this is a non-monic polynomial. Okay, and non-monic means that that's a number other than 1 there. So what we're going to do here is go to our calc and define a function. So define f of x equals 2x cubed, take away x squared, take away x, take away 3. And what I'm going to do then is slam in values that are factors of 3 to find a factor. So f of 1, no. F of -1, no. F of 3, no. F of -3, no. So none of them equal 0, which means that x plus 1, x take 1, x plus 3, and x take 3 are not linear factors, okay? So what we're going to conclude here is that p of 1 and p of -1, p of 3 and is not equal to 0, is not equal to 0, is not equal to 0, and p of -3 is not equal to 0. Okay, so none of the factors of 3 allowed us to generate solutions, but this could have a fraction for a solution, i.e. maybe p of a half, maybe p of a third. Okay, so what we're going to do is further engage and have another look at this. And again, this is why equating coefficients is such a strong method, because the skill allows you to think through what could be the solutions to this problem. All right, so what I know is when I factorize this, it's going to have like a situation where it looks like that multiplied by, say, quadratic. Okay, so what we're going to do is say p of x could equal this linear factor and this quadratic factor. Okay, now what I want to think about or start to think about is things that could be in this bracket here. Now I know it's not x take 1 or x plus 1 or x take 3, x plus 3, because I've already tried those ones. Okay, so what I'm going to do now is pop this down. See if you can understand what I'm doing here. I'm going to put down 2x out here, and I'm going to put in x cubed in here. Now 2x multiplied by x cubed would give us 2x cubed. Okay, now what I'm going to do is think about what my constant could be. So this could be -1, in which case this would be +3. All right, so that could be an option. It could factorize like that. Now there are other options. It could be 2x, and this could be +1. In which case this would be x cubed, and that would be take 3. Now note, I'm not too worried about the middle term at the moment. There is another one. It could be p of x equals 2x take 3, in which case that would be x cubed, and that would be +1. And there's one final configuration that it could be, which is 2x plus 3, in which case that would be x squared. I'm doing cube there, I don't know why. That should be squared, 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 and squared. And this one would be plus, no, take 1. All right, so it could be that, it could be that, it could be that, and it could be that. So by inspection, you'll find that we have 4 options. That one, that one, that one, that one. And what we're going to do is use the remainder theorem. Now, how do I test whether this is a factor? Well, recall that what I do is I imagine that is equal to 0, in which case x is equal to a half. And I do p of a half, all right? This one here would be p of negative a half. This one here would be p of 3 on 2. And this one here would be p of -3 on 2. So I'm going to try out each of them on the calculator, or if it forces you to do it, by hand. So let's do f of a half. No. F of negative a half. No. F of 3 on 2. Bing, 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 bing. We have a winner. Okay. So f of 3 on 2, or p of 3 on 2, equals 0. That didn't equal 0. That didn't equal 0. And I bet you that won't equal 0, but let's confirm that. There it is. So what we're going to conclude is, therefore, this one was this one here. 2x take 3 is a factor. All right, so what I want you to do with these rational root problems is use your calculator to speed up the testing process, okay? Now, ultimately, what you actually could do if you had a calculator is, of course, do a transform and factor, R factor, and actually get it to factorize the function, okay? So there it is there. What R factor does, let's just try factor. So there's our linear factor there, 2x take 3. So that would be another way of doing that problem, but it means that you don't understand rational root. The calculator is just feeding you an answer, okay? So what you want to make sure that you actually do is go through this process and think it through. Because I can think of a couple of ways in which I could write even a tech active question that if you don't understand rational root, you will have a problem with this question. All right, so find a factor of this polynomial. Okay, so what we're going to do is, again, a bit of trial and error. And note that this first term here could be, well, so what I would note, let's define that function. Define f of x equals 3x cubed plus 8x squared plus 2x take 5. And you would do the usual f of 1, f of negative 1, f of 5, and f of negative 5, and find that none of them produced 0. So looking at the factors of that, none of them would be factors. So that means that we need to further engage and imagine that this one here could be actually a fractional factor. Okay. So now our job is to really test the possibilities. So this could be 3x, forget that, that's not supposed to be anything, and this could be x squared, okay? Now this could be plus 1, in which case this would be negative 5. So there's one of the possibilities, 3x plus 1. Let's consider some of the others. P of x could be 3x take 1, because this would be squared and this would be plus 5. So that's a possibility as well. P of x equals 3x plus 5 is a possibility, because this could be negative 1, again, when they're expanded. So I'm thinking about what it would look like when they're expanded. And P of x could be 3x take 5, in which case that would be x squared plus 1. All right. So we've exhausted all of the options there. So that means our winner is going to be coming from one of these options. So what I'd be trying out this one here would be P of negative a third, P of 1/3, P of 5 on 3, and P of negative 5 on 3. So I'm looking for one of those. All right, so let's go to the calc and speed up the process, because there's no way I'm subbing those values into a cubic. F of negative a third, nope. F of 1/3, no. Okay, F of 5 on negative 5 on 3, let's do first. There's our factor, F of 5 on 3. I was trying to save the factor till last to increase the tension there, but I couldn't work it out that way. So that is negative 5 on 3 is 0. That's not equal to 0. That's not equal to 0. And that's not equal to 0. So that's our winner. Okay, so that one came from this one here. So we're going to say, therefore, 3x plus 5 is a factor, which is what it was trying to get us to do. All right, so your work now will be to finish this exercise off, and I think it will be those questions there. Okay, so I think you've, for homework in the last lesson, you've done those. Okay, and let's forget the handout for the moment.